Good morning and welcome to everyone. Today we will be speaking in this podcast that delves into the intricate and fascinating world of ecological science. In today's episode, we explore the realm of one of the most enigmatic and revered reptiles on the planet, which is also known as the king cobra. How can mathematical models and simulation help us understand their behavior, distribution, and interaction within the ecosystem? So to start with, I will invite Hanisha to start the podcast by delivering the first part, which is the introduction. Can you introduce and the impact of this study finding?
Thank you, Miss Moderator. The king cobra is the longest venomous snake at 3 to 5 meters compared to other snakes. Researching the distribution of king cobra in Peninsular Malaysia is crucial due to help conserve biodiversity and enhance ecological knowledge about species-environment interaction. That's all for my part.
Thank you so much, Hanisha, for the well-delivered explanation. Now we would like to hear about the methods in this ecological modeling. So Asma, can you explain about the methods to everyone here?
Alright, thank you, Ivy. For the method, step 1 are using GBIF to gather species data. And the step 2 are using the GeoCat for conservation assessment. And for step 3, using medicine for incident management. By using GBIS, GeoCat, and medicine in combination, you can compress, study, and manage the Cobra in Malaysia. That's all for me. Thank you.
Thank you so much, Asma, for the explanation. For the next one, we will go through the ENM. I would like to ask Shahira, based on the information provided, what might be a potential limitation or concern regarding the ENM results for the king cobra in this study?
Thank you, moderator. A potential limitation or concern regarding the ENM results for the king cobra in this study is the poor performance of the model. As indicated by the low AUC value, this suggests that the model predictions may not be reliable for making strong inference about the king cobra's distribution in the region. Thank you.
Thank you, Shahira, for your answer. Now we will go ahead to the next one with a focus of understanding area under the curve. So, Ismahani, could you please start by explaining what AUC and its relevance to our study?
Thank you, moderator. I will explain the concept of AUC or area under the curve and its application in our King Cobra ecological niche model project. AUC is a crucial metric for evaluating the performance of classification models. Based on the result, our AUC is 0.454, indicate that the model has pure discriminatory power and performs slightly worse than random prediction. An AUC of 1 indicates a perfect model. Value between 0.5 and 1 suggests the model performed well. That's all from me.
Thank you, Ismahani, for the well-present answer. Next, I would like to ask Aisha, can we see the result from EOO and AOO?
Sure. Let me talk about EOO and AOO based on IUC area list. For EOO, its IUC area list for King Cobra is least concern with 69,556.314 kilometers square for its distribution area. And for AOO, the IUC area list is enlarged with 48 kilometers square distribution area. That's all from me.
Thank you, Aisha, for your answer. Now we will be hearing about comparative analysis presented by Siti Mariam. What can we learn from the comparative analysis of EOO and AOO in terms of conservation priorities?
Thank you for the moderator. As we can see in the poster and the result of the EOO and OO, The significant difference between EOO and AOO suggests that king cobra have a broad potential range but occupy a much smaller area. This highlight that need to focus on protecting critical habitat between the AOO to ensure the species survival. Despite the large EOO, the king cobra might be classified as vulnerable or endangered due to its small AOO, indicating a higher risk category. That's all.
Thank you, Maria, for the answer. Next, we will be hearing from Hakimi about his part on conservation implication. How can the Maxon modeling approach be utilized to be predict to habitat suitability and conservation needs of the king cobra?
So from the results of the model, it can inform the conservation strategies by pinpointing regions where the conservation effort should be focused. So such as habitat restoration, protection from human encroachment, and mitigation of threats like poaching and habitat disruption. So from all these information gains, overall, the Maxim can provide a valuable tool for guiding the conservation action to ensure the long-term survival for the king cobras.
Thank you, Hakimi, for your answer. So now we are getting close to the end. I would like to invite Afif to conclude the podcast. How does the understanding the extent of occurrence and the area of occupancy of the king cobra contribute to concluding its conservation and strategies?
Thank you, Ivy. To conclude, by analyzing both EOO and AOO, conservationists can determine the species distribution patterns and identify critical habitats that require protection. This data helps in assessing the species' vulnerability to threats such as habitat destruction, human-wildlife conflict, and climate change. Consequently, it aids in formulating targeted conservation strategies, prioritize areas for habitat restoration, and implementing measures to mitigate threats. Overall, understanding EOO and AOO is essential for making informed decisions to ensure the long-term survival of the king cobra. That's all.
Thank you so much, Afif, for your conclusion. So now we have finally reached the end of our podcast today. So we hope you enjoyed learning about the king cobra and the role of ecological modeling in understanding this creature. Thank you so much to everyone here for your contribution in this podcast. And that's all from me. Thank you.